Hello viewers, welcome again. This is Mr. Odingo, trying to make you understand chemistry. It's a very important subject in science. Since we began, we have been discussing about matter, and today I want us to go further to understand what we call changes of states of matter. If we have the three states of matter, we can change one state to another and one to another. And that's a very key point. And now that is going to be easier because we have understood what kinetic theory of matter is. We have been able to understand how movement, spaces, what we call arrangement, and also kinetic energy changes between the three states of matter. Today, we want to look at those changes of states of matter. If I have one state of matter, for example, solid, is it possible I can get liquid out of it? And if I have liquid, is it possible I can get gas out of it, or vice versa? Now today we want to look at the three states of matter and what do we need to do to change these states of matter. And learner, if you're watching this video now, to change one state of matter from one to another is simple. The only thing you need to do, you need to heat or you need to cool. And that's what we have to do. So two things we are going to do to change our states of matter today. We heat solid, we change it into liquid. We heat a liquid, we change it into gas. Or we cool a gas, we change it to liquid. Or we cool a liquid, we change it into solid. So without wasting time, I want to draw my three states of matter. And in this experiment trial of today, I want to use my three rectangles. Now you know my three rectangles. I'm not drawing them to scale, but they are very important if you are going to understand this particular point here. And these three states of matter, I want to call the first state solid, the second gas, the second liquid, and the third one gas. So this one is solid state, this will be liquid state, and this will be gas state. And then I will draw my small circles to represent particles of matter in solid state. So these particles here of solid state, if we can show these ones, we can show that's liquid, and finally I can say this is how gas particles are. So I want us to see, and all of us, we have seen one solid that is very common: ice, water, and water vapor. We know ice is the name of water in solid state. The name of water in solid state. We know water is very common, so I'll use the word water in solid, liquid, and gases. For us to change solid into liquid, if you want to change ice into water, we need to heat, and that heating, we are going to produce what we call melting. So change of state of matter from solid to liquid is called melting. When I change liquid into gas, that one is called evaporation. So this one is evaporation. And then what about if I have to change gas into liquid? This one here is condensing or condensation. That one is the change of state of matter from gas into liquid. What about liquid to solid? Change of state of matter from liquid to solid is called freezing. It's called freezing. These are four changes of state of matter that we see daily. They happen on daily basis: melting, evaporation, condensing, and freezing. But we have a fifth change of state of matter, which comes from solid directly to gas. This change here is called sublimation. This change here is called sublimation. It's the change of state of matter from solid directly to gas without first passing through the liquid state. And then finally, the last change of state of matter, we have this one, from gas to solid directly, and this one is called deposition. Deposition is the change of state of matter from gas to solid. These are the interconversion. This is why we call them interconversion or changes of states of matter, the interconversions between the three states of matter. In these three states of matter, I want to go deeply a little to be able to explain a few things. When substance is melting, we normally say, if someone asks you what is the definition of melting, we say it's the change of state of matter from solid to liquid at a constant temperature. Why do I mention the word constant temperature? because when a solid is melting, the temperature will try to remain constant. Why? As I said in kinetic theory of matter, that particles of matter have some forces of attraction between them. If I draw this small graph here to be able to illustrate the melting of water, I say water is melting from -10, for example, degrees Celsius. This is temperature, and I said temperature, we are measuring the temperature in degrees Celsius. There, this one is time, and they say this time is in minutes. So we want to see if you are heating water from -10 degrees Celsius, this is 0, and this one is 100. This is 100 degrees Celsius. So we have 10, and we are heating our water, our ice, from -10 degrees Celsius. The temperature will rise. As you heat water or ice, the temperature of ice will increase from -10 to 0 degrees Celsius. When it reaches 0 degrees Celsius, you continue to heat, but the temperature will remain constant. The temperature will remain constant for some time, and then it will start rising again. The question here is, what is happening where the temperature is not rising, but you are heating? Where is the heat going to? The heat energy you are putting in at this particular point at 0 degrees Celsius for about some few minutes or some few seconds there, that amount of heat that is absorbed at that particular point is used to break the bonds. The forces of attraction, I say that particles in matter have forces of attraction between them. The energy you are putting in is overcoming those forces to be able to separate, to move those particles apart. Because we agree that when you heat something, the heat energy is converted into kinetic energy. Kinetic energy makes particles move. As they vibrate with a lot of force, they weaken the forces of attraction between those particles, and that is what is happening at this particular point. So the heat energy absorbed in this particular point here is not used to raise the temperature, but the amount of energy absorbed here is used to break the bonds that are there in solid state. That is enabling the particles to move, separate far apart to be able to form the liquid state. So that's why I'm defining melting as the change of state of matter from solid to liquid at a constant temperature. If I come to evaporation here, where we are converting liquid to gas, again from this point here, let me use letters to label this as A, this is point B, this is point C. At the point where we have 100 here, this is point D. At this point here again, we have, let me say A, B up to F. At this point, from C to D here, you see that the temperature is rising. We are heating and the temperature again is rising from 0. The substance now, water here, is liquid state at this particular point here. We start heating that liquid, the temperature rises up to 100 degrees Celsius. When the temperature is 100 degrees Celsius, again we see something here. The line remains flat. Why is this line remaining flat at this particular point? The line is remaining flat because the amount of energy we are putting in is used to overcome the forces of attraction that are holding the liquid molecules together, the liquid particles together in liquid state. And we know that these forces of attraction holding the liquid particles in liquid state together are called the hydrogen bond. They are intermolecular force of attraction holding the liquid particles in the liquid state. In the solid state, the forces of attraction we are overcoming here are called weak van der Waals forces. So we have weak van der Waals forces here, and then we have hydrogen bond there. You realize that if you look at here, the length of this line here is short. The length of this one is longer. It means it takes shorter time to change solid into liquid, but it takes longer time to change liquid into gas. Why? Because hydrogen bonds in liquid state are stronger than the weak van der Waals forces in solid state of ice. Above this E here, water is now a gas. So I can say that between E and F, now we have water vapor. We have water vapor, or sometimes we can use the word steam. We can use the word steam to refer to water in gaseous state. Between C to D, the water here is in liquid state. So liquid state of water is just called water. That's the name of water in liquid state. What about here? Between here, this water is solid, and we use solid, name of water is ice. So we have these changes of state of matter. The solid is here, the liquid here, the gas is here. What is happening here? This is melting. Between B to C, that's melting. between D to E, that is evaporation. Now, this graph I've drawn as sharp melting and boiling points. We can see it is as sharp as we can see. For an impure substance, for example, a mixture of water and something else, maybe water and ethanol, when you are heating, you are not going to get specific or sharp melting and boiling point. The curve you are going to get when you are heating water, a mixture of water and ethanol, for example, from negative degrees Celsius will be something like a wave that way. Why is it going to be smooth curve like this? Because it's a mixture. One will boil at 100, for example, water. Ethanol will boil at 78 degrees Celsius. So you'll be having different points that will end up in a smooth curve. So if you are asked to meet something like this in examination, this smooth curve here represents an impure substance. This one here represents a pure substance with sharp melting and boiling point. When I want to move further to something else, as I come to the end of this lesson, I want to come to what we call sublimation and deposition. This is a very unique change, and sometimes people don't believe that it takes place. Most students ask me, Mwalimu, no, we have seen solid changing into liquid and not gas. Or where do you come with this kind of change here? And I say, not everything will have this kind of deposition or sublimation. There are special substances that can undergo sublimation or deposition. Whatever can undergo sublimation will undergo deposition because they are opposite each other. Just like melting is opposite freezing. Evaporation is opposite condensation. Sublimation and deposition. They are changes of state of matter that we are saying they are skipping the liquid state. It's changing directly from solid into gas. And it's very important for us to know which substances can undergo sublimation. And I will mention number one. Number one that can undergo sublimation, substances that can undergo sublimation. These substances, there are a number, but it's up to you to know which ones you need for the purposes of preparing for your examination. Number one of these substances is iodine. This is a very common substance that undergo sublimation. When you heat iodine, is a gray substance. If you heat iodine, it will turn into vapor. Iodine vapor. So, number two, other than iodine, is what we call ammonium chloride. Ammonium chloride is a salt that can undergo sublimation. Number three, we have aluminum chloride. Aluminum chloride is also a salt. Aluminum chloride can also undergo sublimation. Number four, we have iron 3 chloride. Iron 3 chloride can also undergo sublimation. Finally, I can talk about what we call dry ice. Dry ice. I've never seen dry ice, but dry ice is recorded as some of the substances that can undergo sublimation. It's ice that when you touch, it has been cooled, frozen to that extent when you touch it, it doesn't leave wet marks in your hand. It means it's totally dry. When you heat that ice, it turns into gas. And that is very, very important for you to understand. Thank you, viewers, for that lesson, and welcome. If you have any questions, please make sure to subscribe, and then ensure you can also write for us emails, like us on Facebook, as we try to help you achieve your goals academically. Thank you.